Hello everyone. So, this is the fourth lecture on conic sections. In the first three lectures, we learned the standard equations of parabola, ellipse and hyperbola and looked at some simple problems. So, let us continue our discussion. So, let us recall standard equation of a hyperbola is of the form x square by a square minus y square by b square equal to 1 or y square by a square minus x square by b square equal to 1. So, this is first and this is second form. The first form, the graph of this hyperbola looks like it has two branches and this center is at the origin. The vertices of the hyperbola are at point a comma 0 and minus a comma 0. This is obtained by putting y equal to 0 in equation 1, we get x square is a square. So, x is plus minus a and the focus, there are two focus. So, let us call f 1 and f 2. These have coordinate c comma 0 and minus c comma 0. Where c square is equal to a square plus b square. This is the first one, and the second form here if you put x equal to 0, then we get y equal to plus minus a. So, vertices are at point 0 minus a and 0 a, and the hyperbola looks like this. And here again the foci are at the point 0 comma c, 0 minus c, and again c square is given by a square plus b square. So, we looked at two examples in the last class. Let us do some more problems. So, find the equation of the hyperbola whose vertices are at plus minus 2 0 and foci at plus minus 3 0. So, since the vertices are on the x axis, since the vertices are on the x axis, the equation of the hyperbola is of the form x square by a square minus y square by b square equal to 1, Here it is given that vertices are at plus minus 2 0, vertices of this hyperbola are at plus minus a 0 and foci are plus minus c 0. So, in the given problem a is equal to 2 and c is equal to 3. In this equation we need the value of a and b. So, we have a square plus b square equal to c square. This implies b square is c square minus a square, which is equal to 5, and therefore, the equation is x square by a square, that is 4, minus y square by b square is 5 equal to 1. Now, let us look at second problem. Here you are given that vertices are at 0 plus minus 5 and foci at 0 plus minus 8. So, in this the equation will be of the form y square by a square minus x square by b square equal to 1, because the vertices are on the y axis. The equation is of the form y square by a square minus x square by b square equal to 1, where a is given to be 5 and c is given to be 8. So, from this we can again find b, therefore, b square is c square minus a square, which is 8 square minus 5 square. So, that gives 39, and therefore, the equation is y square by a square 25 minus x square by b square is 39 equal to 1. Let us look at one problem where you are given foci and the length of lattice rectum. Find the equation of the hyperbola whose foci are at plus minus 4 0 and the length of the lattice rectum is 12. So, again since foci are on the x axis, the equation is x square by a square minus y square by b square equal to 1, and foci at plus minus 4 0, this implies c is equal to 4, that is a square plus b square is equal to 4. Recall that length of the lattice rectum length of lattice rectum L is given by 2 b square by a. This is given to be equal to 12. I have this one equation and then 2 b square by a equal to 12. This implies b square is equal to 6 a. Putting this in equation 1, we get a square plus 6 a equal to, this is a square plus b square is c square equal to 4 square. So, therefore, this is equal to 16 and this implies a square plus 6 a minus 16 equal to 0. You can easily factorize this as a minus 2 times a plus 8 equal to 0. Since a is positive, this implies a is equal to 2. So, a is 2, therefore, you can calculate b. Therefore, b square is equal to 6 a, which is equal to 12. This implies we need b square and a square. So, therefore, the equation is x square by a square is 4 minus y square by 12 equal to 1. Let me do one more simple problem. You have to find the equation of the hyperbola whose foci are at 0 plus minus root 10 and which passes through, the hyperbola passes through the point 2 comma 3. So, foci is given to be 0 plus minus root 10. This implies c is equal to root 10. Also, the equation is, because the foci lies on the y axis, equation is of the form y square by a square minus x square by b square equal to 1. And since this equation passes through, since it passes through two comma 3, we get 3 square 9 by a square minus 2 square by b square 4 by b square. This is equal to 1. This is equation 1, and second equation we get in terms of a and b by using c is equal to root 10. Also, a square plus b square equal to c square, which is 10. This is my equation 2, and using 1 and 2 we can solve for a and a square and b square. So, from here we can write b square is equal to 10 minus a square, and putting this in equation 1 gives 9 by a square minus 4 by 10 minus a square equal to 1, which implies 9 times 10 minus a square minus 4 a square equal to a square times 10 minus a square, which implies 90 minus 9 a square minus 4 a square equal to 10 a square minus a to the 4. This gives a quadratic in a square. So, this gives a to the 4 minus, we have 10 here and 9 plus 4 is 13, 23 a square plus 90 equal to 0. And now, you can find a square from here. So, this implies we can write this as a square minus 5 times a square minus 18 equal to 0. This implies a square equal to 5 or a square is equal to 18, but a square plus b square, this is given to be 10. This implies a square is less than equal to 10, hence a square must be equal to 5, and then using a square plus b square equal to 10, this gives b square is also 5. Therefore, the equation is y square by y square by a square is 5 minus x square by b square 5 equal to 1. So, in this case a and b are equal, that is same thing as y square minus x square equal to 5. Okay, so far we have looked at the standard equation of hyperbola and then seen some problems on finding the equation of hyperbola given vertices, foci or some points on the hyperbola, etc. Now, let me talk about what is called asymptotes of a hyperbola. So, consider the hyperbola x square by a square minus y square by b square equal to 1. So, if we draw this hyperbola, this has vertices at a 0 and minus a 0. Foci are at the point c comma 0 minus c 0. And the graph it looks like this, it passes through these vertices. Now, let us look at so we have a and c are the coordinates of this vertex and this focus. Now, where is B? What we have is a square plus b square equal to c square. So, if I, this is the origin, if I draw this circle centered at the origin and radius equal to c, I get this circle. Now, what we have, a square plus b square equal to c square. So, if I draw a right angle triangle where this is length is a and then the perpendicular is here, this length is the radius of the circle is c. So, you can see here that this height of this right angle triangle is given by b. So, b is this length. Now, let us look at this straight line. So, this is the straight line whose slope is b by a, and we can look at another straight line whose slope is minus b by a. So, if I do the same thing here, I have again this length is c, and this is a, therefore, this will be b. So, this straight line has slope minus b by a. So, let me mention this. This is the line y equal to b by a x, and this line is y equal to minus b by a x. Now, let us first see whether these straight lines, whether they intersect with the hyperbola or not. So, if we see the straight lines y equal to plus minus b by a x do not intersect the hyperbola x square by a square minus y square by b square equal to 1, because if y is plus or minus b by a x, that is, if there is a point lying on this one of these straight lines, this will imply that y square by b square is same as x square by a square, which will imply that x square by a square minus y square by b square is equal to 1. Hence, x comma y x square by a square minus y square by b square is equal to 0, but the equation of the hyperbola is x square by a square minus y square by b square equal to 1. So, any point on these straight lines x comma y does not lie on the hyperbola. So, these lines they do not intersect the hyperbola. However, if you look at the line y equal to b x and this hyperbola, as x tends to infinity, we can show that the line and this hyperbola, they both tend to the same. So, what I want to say is, however, if you look at the any x comma say a x comma y on the hyperbola, if x comma y lies on the hyperbola and x comma say y 1 lies on the line say y equal to b by a x, then what is y minus y 1? So, y lies on the hyperbola. So, y can be written as b times square root of x square by a square minus 1, and y 1 is on the line. So, y 1 is b by a x. Actually, if you see, if I take any x here, and this is my x comma y and this is my x comma y 1. So, this difference in the y coordinate is actually y 1 minus y. So, let me take mod of this, which is equal to b by a, and then we have x minus square root of x square minus a square. Now, what happens if you have done calculus, you can try to find what happens as x tends to infinity. So, as x tends to positive infinity, what is limit of x going to infinity of x minus square root of x square minus a square. To evaluate this limit, we can write this as limit x tends to positive infinity, you multiply and divide by the conjugate. So, x plus square root of x square minus a square times x minus square root of x square minus a square divided by x plus square root of x square minus a square, and then the numerator is x square minus x square minus a square divided by x plus square root of x square minus a square, which is equal to limit x tends to infinity of a square divided by x plus square root x square minus a square. So, the numerator is finite here, denominator is x plus square root x square minus a square, this goes to infinity. So, therefore, this goes to 0. Therefore, the line y equal to b by a x and hyperbola x square by a square minus y square by b square equal to 1, approaches each other as x tends to positive infinity. Similarly, you can do for the other line and taking x tends to negative infinity. So, these lines are therefore the asymptotes of the hyperbola. So, the line y equal to b by a x and y equal to minus b by a x, these two are asymptotes. Now, one definition: if a is equal to b, then the hyperbola is called a rectangular hyperbola, or sometime it is called equilateral also. So, rectangular or equilateral hyperbola. This is because in this case the asymptotes are y equal to plus minus x, and these are perpendicular to each other, which are perpendicular to each other. So, in this case we have x square by a square minus y square by b square equal to 1, which and b is equal to a. So, we have x square by a square minus y square by a square equal to 1, which implies x square minus y square equal to a square. So, if you draw this hyperbola, then here these lines y equal to x and y equal to minus x, these are the asymptotes, and we have this vertex a comma 0, and the hyperbola will have these lines as the asymptotes. And in this case, say the vertices are at the point a comma 0 and minus a 0. Because b is equal to a, the focus will be at the point root 2 a 0 and minus root 2 a 0. Right, because a square plus b square is c square. So, c is this is f 1 and f 2 the foci. Okay, so, we have this rectangular hyperbola x square minus y square equal to a square. This can be written as x minus y times x plus y is equal to a square. and in this case what we saw is that we have y equal to x and y equal to minus x. These are the asymptotes which are perpendicular to each other. Now, if we make a change of variable and putting say x dash equal to x minus y and y dash equal to x plus y, we get x dash times y dash equal to a square. So, that means that what we are doing, instead of taking this axis as x axis and y axis, suppose I take this as x dash and this as y dash, then what we get is this, or let us call this axis as the x dash and this as y dash. Then we have x dash times y dash equal to a square. So, this gives another form of rectangular hyperbola. Rectangular hyperbola, that is x times y equal to a square. So, this is more standard form of rectangular hyperbola. If you draw this hyperbola, now the asymptotes will be x and y axis and the hyperbola is like this. Right. So, this part is y equal to a square by x for x positive and this is for x negative. So, here the graph is in the first and third quadrant and the asymptotes are x axis and y axis. Asymptotes are x axis and y axis. Now, let us say as a special case, if a is equal to 1, we get x y is equal to 1 or y is equal to 1 by x. So, you might be familiar with the graph of this function y equal to 1 by x. This looks like this, the graph is in the first quadrant and the third quadrant. It is defined for all x non-zero, and as x goes to infinity, this goes to 0 and x goes to negative infinity, again it goes to 0. As x goes to 0 from the right hand side, then y approaches plus infinity. As x goes to 0 from left hand side, y approaches minus infinity. So, now let us try to find, let us find the vertices and foci of the rectangular hyperbola x y equal to a square. So, we have this rectangular hyperbola. Clearly, here the center is at the origin. So, this is the center O, and the vertices of this hyperbola will lie on this line y equal to x. So, here we have this is the transverse axis, and the line y equal to minus x is the conjugate axis. The vertices, suppose the coordinate of this vertex is a comma a, then this vertex will be minus a minus a. This is because this vertex x and y coordinates are same. So, x times y is a square. So, we get a and a. So, vertices are a comma a and minus a minus a. What about the foci? So, we know that foci will lie somewhere here, let us say c comma c and minus c minus c. So, let foci be c c and minus c minus c. Then what we know is that for this rectangular hyperbola, a is equal to b. So, since a is equal to b for rectangular hyperbola, we have c square equal to 2 a square, which means c is equal to root 2 a. So, the foci are at the point root 2 a and minus root 2 a minus root 2 a. These are f 1 and f 2. Right. So, we have found the foci root 2 a and minus root 2 a minus root 2 a. We can also obtain this by using the basic definition of hyperbola. So, let us find the foci of x y equal to a square using the definition of hyperbola. So, we have this hyperbola x y equal to a square, center is at the point 0 0, and because the hyperbola is symmetric about the transverse and conjugate axis, we have this line y equal to x as the transverse axis and y equal to minus x is the conjugate axis. So, the vertices are at the point a comma a comma a comma a and minus a minus a. Suppose the foci are at the point, this is f 1 is some c comma c and f 2 is minus c minus c. This foci also lies on the transverse axis. So, we get this. Now, if I take any point P, so by the definition of hyperbola, if P is any point on the hyperbola, say P lying in the first quadrant, then P of f 2 minus P of f 1. So, the difference of the distance of any point from the foci is constant 2a, right. So, P of f 2 minus P of f 1 is equal to 2a. Now, we can take the point. So, let P be the point whose x coordinate is c. So, if we take say this point P, his x coordinate is c, then y, what is y coordinate? Because x times y is a square, this will be a square by c. So, P is c, a square by c. Now, if I calculate the distance of this point to f 2, so P f 2 will be square root of c plus c square plus a square by c plus c square, and P f 1 is equal to c minus a square by c, because this same x coordinate. So, P f 1 is this. So, I think we made a mistake here. So, the difference of any point P f 2 minus P f 1, this must be constant, but the constant is equal to the distance between the two vertices. If I call this A and B, this is not 2a, this should be equal to a b, which is equal to 2 root 2a. Four c square plus a square by c plus c whole square square root equal to c minus a square by c plus 2 root 2 a. This implies 4 c square plus a square by c plus c whole square equal to c minus a square by c square plus 8 a square plus 4 root 2 a times c minus a square by c, and this gives 4 c square plus 4 a square equal to 8 a square plus 4 root 2 a c minus 4 root 2 a cube by c, and then solving this we will get c is equal to root 2 a from here. So, therefore, the foci are at the point root 2 a and minus root 2 a minus root 2 a. So, this finishes today's lecture. In the next lecture, we will learn something more about parabola, ellipse and hyperbola. Thank you.